Let's talk about concepts of routing. We have experienced some of the example, a very simple example, like VLAN, inner VLAN routing. So in this lesson, we just get into routing in some details. So routing is equivalent to L3 routing because routing always happens on the third layer, which is network layer. So we have IPv4, we have IPv6 as the two biggest protocol on the layer 3. So for layer 3, we have 4 operations addressing because we have to put all of the endpoints, client or servers, all the services with different IP subnets. So that means we call this process as addressing or subnetting. So encapsulation and decapsulation means that we have our real data from the layer 4 or upper layer. So we just encapsulate the real data by adding the IP header, and then we throw this packet to a lower layer. This is encapsulation. So on the contrary, we have decapsulate from the lower layer to a higher layer. So just get rid of the IP header and just retrieve the real data and send the real data to the upper layer, which is layer 4. I also have routing. Routing always happens in the middle of the network devices, like this cloud shown here. So let's take a close look at routing. So routing always happens on a router, and a router is a node that performs a routing function. So what happens when the router receives the packet from the host devices, like this diagram, the PC1 sends out a packet to PC2, but because PC1 and PC2 are different IP subnets, so that they have to send the packets to this default gateway as a first step. So the R1 received this packet from this interface, which is a gigabit 000/0/0/0. So they just examine this packet's destination and try to search for the best path by checking their routing table. So just R1, by checking the routing table, R1 just made a decision how to forward this packet. So by using this routing table, like this table, they just find out that R2 is their NAS hop. So the R1 sent this packet to R2 via this NAS hop address, star 226. So R2, likewise, R2 does the same function, does the same operation by checking this its own routing table and try to find out the best path for the destination. Because the destination is on their direct connected link. So R2 will just send out the packets directly to the destination, which is PC2. So you can see the whole process that includes the first hop, which is the hop that the packet reaches their default gateway, and the last hop, which is reach to the destination. And in the middle, we have a might be pretty complicated networking or routing protocols by using so many routers. So when we look at the routing table, there are three different types of routes in the routing table. Or I also called routes or route entry in the routing table. So you can see that there's if when it comes to R1 or from R1 point of view, there are two direct connected network because they are surely direct connected subnet, which is 192.168.10.0 20 slash 24 slash 24 and this one. So if these two if PC1 wants to connect to this direct connected host, R1 just automatically route this packet. You don't need to configure any. You don't need to add any any more configurations, or you don't need to leverage any dynamic protocols because these two are directly connected. R1 naturally know these two existence. For this remote network, R1 does not know. So by using like a static manually config static route and or by using the dynamic routing protocol, R1 just finally got this remote network or learn this remote network or remote subnet. So when it comes to static routing, we just manually configured a route to this specific subnet. For example, here IP route, this specific route, and then finally at the last part you give it the next hop. That means that when you want to get to this IP subnet, please send it to the next hop, which is this IP addresses. So this is a static route, which is manually configured. So because the being manually configured route, there's a lot of downsides. Because if you imagine that there's a pretty complicated or many IP subnets, you have to configure manually configure many routes on every router. This process is prone to error and is not very flexible because when the topology changes, you have to change your static route manually, or just like this topology. If you configure a static route by using this next hop, but this next hop is invalid when this link failed, the R1 definitely has alternative physical alternative path to get to this IP subnet, but R1 doesn't know because there's no any entry or no route in their routing table. So you have to leverage the dynamic protocol to deal with the topology change. So here's the dynamic routing. So you can see that no matter how many routes IP subnets you're gonna use and how complicated your network is, you can use dynamic routing protocol to automatically learn the subnets, even very far away from you. And when topology changes, the dynamic protocol will be converged automatically, and all of the you can use this automatic convergence to achieve this automatically reroute. So here's another important feature or concept, which is the military distance. So just imagine that there's, let's say, there's a specific subnet, but you have to learn this subnet via ERGRP, which is a specific routing protocol. You also learn this specific subnet via OSPF. So there's a two protocol you learn from. So how do you prioritize which one is the best? So that is what administrative distance is all about. So just for example, here's this a list. The lowest administrative distance will win, and this lowest route with lowest distance will be inserted into routing table finally. So because if you learn different routing protocol, every protocol has its own rules for calculating metrics or cost. So you can directly compare this metrics or costs between the different protocols, just like that's Apple. You compare Apple to Orange. There's a totally different two things. So by using administrative distance, you can just prioritize which one is the best, and they will be finally inserted into routing protocol and take the effect. And here's a real routing tables. You can see this routing table by typing show IP route on Cisco routers. And there are some of the symbols to represent different types of routes. For example, we already talked about directly connected network denoted by C and L. Actually, you don't need to care about L entry, because L entry is automatically created, and it also overlapping with the C entry. If you can see, this L entry is always a host route. /32 means this is a host route. And the S means static route, but manually configured by you. And OSPF and ERGRP and R for RIP is totally different dynamic protocol. So you might have noticed that there's two numbers. The first number is administrative distance. So for OSPF is 110 is their OSPF administrative distance, sorry. For static route is always 1. So a static route always wins over any dynamic routing protocols, because the administrative is the lowest. And the second number is their metric or cost, or metric. 2, this means different metric. Uh, Generally speaking, the lower metric will win when compared with the same protocol, uh, same route with via same protocols.